However, I don't think that they really expect you to use trig to figure out these sides. For an isosceles triangle, we shouldn't need trig to figure these out. We should be able to figure out these sides using the Pythagorean theorem again. We should be able to figure out these sides using the Pythagorean theorem. Do you see what I mean by that? How could we do that?
These two are equal, so this would be. Could I just do? If I just call them both x or something.
Okay, yeah, you can call those both x.
So it'd be 2 x squared.
If we just make up a variable, say x for both of those, because the x component will be equal to the y component. Now don't forget that we're squaring the left-hand side. So do we get this?
And divide by 2. And you take the square root to find each side.
Right, good. Yeah, this is a mess. Let's take the square root first. If we take the square root first, what do we have left on the left-hand side? Just k q naught q3 over 2d squared.
Yes.
And on the right-hand side, we have this.
Yeah.
Now we can multiply both sides by 1 over root 2. And I got this for the component, k q naught q3 over 2 root 2 d sub 2 squared. All right, now what?
So those are the components of the fourth.
Right?
So
So how can we report our answer so that it'll match what they expect over here?
could you do it by the x and y?
Right?
So
Because are we allowed to include that in our answer?
yes.
Notice that we're allowed to include the x and the y unit vectors in the answer. So the answer would be,
Could I just so could I do it? These are considered x and y, are they, in this problem? Because if this is the y-axis.
oh, yeah, so I shouldn't have been saying x and y.
Yeah.
That was a mistake. I should have said, which components are these? This was the z component, and this was the y component. So that was a mistake that I made. I should have called this the y and the z component to be consistent with the axes they chose.
So what I'm asking is for to solve the problem, can I do it through the z and y components and not the
Right.
Okay. So then it would just be, would it be the square root of each of them? I mean the square.
Now, what's the x component of the overall vector? I'm sorry, what's the y component going to be?
The y component
And how do we show that this is the x component?
Y.
By putting it, whoops, I keep saying x component. What was this supposed to be, the y component? Yeah. By putting a y hat. All right, and what's the z component?
The same thing, but with a Z hat.
So that's our answer. That's the answer that would be consistent with the way they wanted us to report the answer. If you take a look at the variables they wanted us to use, they wanted us to show x, y, and z components. When they say that it should be in terms of x hat, y hat, and z hat, that means that we should be reporting the x, y, and z components here separately. So there's two ways to describe an overall vector. One way to describe the overall vector is to give the magnitude of the overall vector and its angle. And the other way to describe the overall vector is to give its components. But because of the way they told us to express the answer, we know that they want us to describe this in components.
So because it says that using a vector, is there a way to combine the two of them together?
We've already done that on the board. We have combined them. Negative k q naught q3 over 2 root 2 d2 squared y hat minus k q naught q3 2 root 2
that's
d2
minus,
squared.
okay.
This is a minus sign.
Got it.
So I didn't have enough room here to put these on one line, but this is all one big expression.
Okay, well, that makes
That's how
sense.
they want us to express our answer here, is one whole big expression. So yeah, I ran out of room on the board,
That's fine.
but these are two expressions that are being subtracted from each other.
Okay,
So this is a way that we can break a vector into components, but still express it all as one expression.
great, okay. That makes sense.
All right, well, there's a lot of steps there, but those are actually pretty typical, like I said, of the types of things you would see on tests. And you know that on tests, they like to give you problems with variables and not numbers. So this would be a good problem to go back and do the whole thing all over again. There were lots of issues that came up, so this would be a good problem to just go back and do again from scratch. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. Thank you.